section 4-5, part 3. This section is kind of big. We'll probably be in it the rest of the week. And then once we get back from spring break, we'll start into section 4-6. But I first want to put up here our 6 trig integrals. They should be in your notes already somewhere, so if you don't feel like copying all of them down again, you don't necessarily have to. But we are going to be using them a lot today. So remember, if you integrate cosine of x with respect to x, that is always going to equal sine of x plus c. With derivatives, derivative of cosine was negative sine, so this is a little bit different. Now, second one I have up here, the integral of sine of x dx. Well, it's kind of the opposite what it was with the derivatives. Now that equals negative cosine of x plus c. Then the rest of them aren't just single trig functions. These are a little bit different. If you integrate secant squared of x with respect to x, that equals tangent of x plus c. And that should be exactly opposite of our derivatives. Derivative of tangent is secant squared. Derivative of secant was secant of x, tangent of x. So this is opposite too. When you integrate secant of x, tangent of x, dx, it's going to equal secant of x plus c. And 2 more here. When I integrate cosecant squared of x dx, it's going to be negative cotangent of x plus c. And finally, last one, when we integrate cosecant of x cotangent of x dx, it's going to be negative cosecant of x plus c. Now, I only have the integrals up here, but remember, with all of this du stuff going on, we probably will run into some derivatives with trig functions. So we'll have to kind of remember some of those too. They should be in your notes, but we'll go back over some of those if we need to. Now, all of these today are indefinite integrals. So we're not going to get back just a single number. We won't really have anything to plug in once we are done. Okie doke. So, example 1. This is integrating cosine of 3x dx. Cosine of 3x dx. Remember, u substitution is almost kind of like the chain rule with derivatives. If you remember back to derivatives here, anytime I had a trig function of something other than x, in this case it's 3x, to take the derivative of that, you had to take the derivative of the function itself and then come back and take the derivative of the part that was with the x. Then you could rewrite that and you'd be on your way. It's kind of the same idea with this. U substitution works when you have to integrate a trig function of something other than x. If it was just cosine of x, then my answer would be sine of x and I'd be done. Well, this is 3x. So I'm going to come out here to the side and let me explain to you what you usually make u equal. On something like this, usually u is the part right after the trig function, the part with x. I can't say that will always be true, but most of the time that is the case. And so if u is 3x, the derivative of that would be 3 dx. And so let's go ahead and kind of match up everything that we have here like we normally do with u substitution. That is u. So here in the next step, it's going to become cosine of u. But I need to make sure that I have all of du in this integrand. I have the dx, but I don't have the 3. There should be a 3 somewhere out to the side, and I don't have it. So just like usual, if I put the 3 there, I'll have to put the 1/3 out front just to keep everything balanced. So now it says 1/3 times the integral of cosine of u, and then the rest of that stuff in green was du. Okay, so now I have to integrate. I'm going to keep the 1/3 out front. What was the integral of cosine? Sine. So this is sine of u plus c. But remember, you don't want to leave u in your answer. You started with x's, you should end with x's. So I need to go back and put in what u equaled. U was actually 3x. So final answer would be 1/3 times the sine of 3x plus c. Question?
Can that be sine 3x over 3?
Yes, very good question. You could rewrite that. Sine of 3x over 3, that would be the very same thing, just written differently. Yes, that would be fine. Anybody else? Okie doke. Now I'm going to try a few more that have maybe a little bit more going on. This is example 2. And it says 2x times sine of x squared dx. 2x sine of x squared dx. U substitution is good when you have a trig function of something other than x. It's not just x, it's x squared. So like I said last time, usually what you let u equal is the part after the trig function, the part with the trig function. So in this case, it would be the x squared. Now, derivative of x squared is 2x. And like usual, I always put the dx there with it so it matches up to what I have over here. I know that is u, and all the rest of my integrand needs to be 2x dx. And looky there, 2x dx. We have it all, so this might be for you here. Hello. Oh, yes, she's here. Okay, thanks. Bye. That wasn't for you, but it's about 10:30. If you want to head out, that would be fine. Again, I'll put it up on the website here shortly. Okay, we already have everything for du, so I'm going to go ahead and rewrite this. It's just going to be sine of u du. You didn't have to balance it out with anything because you already had everything that you needed. So, what was the integral of sine? Negative cosine. And instead of putting it with u, I'm just going to go ahead and put what u was. That should be negative cosine of x squared, and then plus c. Okie doke. If you already have everything you need for du, then don't balance it out with anything. Let's keep on rolling here. Again, this lesson is a lot nicer, I think, than the one with the chain rule. That was a little tricky. But number 3, secant of 2x, the integral of the secant of 2x times the tangent of 2x dx. Now this looks weird because you have two trig functions, but I'm going to go back here for just a second to our list of trig integrals. And remember, a couple of them do have two trig functions. And in our case, for this example, we have secant and tangent, and that's going to match up really nicely to this one. So like all the rest of our problems, what I have after the trig function, that is usually going to be u. And so du in this case is 2 dx. Now, I already have the u, it's the 2x part. I need 2 dx. I don't have the 2 floating around anywhere, so there it is. And that means we pull a 1/2 out front. So this is now, don't want red, this is now 1/2 times the integral of secant of u tangent of u du. You want to integrate that just like you would with x's. So the 1/2 stays out front. The integral of secant of u tangent of u is just secant of u. I'm going to go ahead and put that back in, plus c. Again, if there's two trig functions up there, it should still match up. Now, that might change a little bit on number 4. We'll have to kind of watch with that one. But we did have an integral for secant tangent, so there we go. Now, if you look at number 4, do we have an integral for sine of something times cosine of something? No, the only ones that had 2 were secant of x, tangent of x. And the other one was cosecant of x, cotangent of x. We don't have a sine times cosine. And so this will have to be done a little bit differently. I'm not going to let u equal the 4x, because if I did that, I'd have to pull a 1/4 out front, but it would turn into the integral of sine of u cosine of u, and this is what I was just talking about. We don't have an integral for sine and cosine together, and there is no product rule for integration, so that is not going to be a good approach. So if that doesn't work, there's actually 2 ways that you could do this problem. If you can't let the part after the trig function be u, then maybe go ahead and let one of those trig functions, the whole thing, let one entire trig function equal u. Now, to take the derivative of this, we do have to use the chain rule. Derivative of sine is cosine. So I start with cosine of 4x, but I have to come back and take the derivative of the 4x, which is 4. And so du is finally 4 cosine of 4x dx. All right, so let's make sure we have all of that. I've got the dx, I've got the cosine of 4x, but I don't have the 4. So I need to pull the 1/4 out front. And now watch how I would rewrite this. The u in this problem is that part. So actually, I'm just going to be integrating u. It's not sine of u or anything like that. That entire function is u. And then all the rest of that stuff is du. So if I think about how to integrate this, this is technically u to the first power. So add 1 to your power, put your new power on bottom. And when I go to simplify that, u is the sine of 4x. And so to make that squared, you could put the entire sine of 4x squared if you wanted. Or if you think back to trig, we did this a lot. Instead of having to use those parentheses with the square, you can also just do sine squared of 4x. That also works. And then 4 times 2 is 8. And then I'll have my plus c. Now what's kind of weird about this problem is that there's another way to do it. And if you do it that other way, you get back a different answer, but technically they're both correct answers. If I had let u equal cosine of 4x, derivative of that would be negative 4 sine of 4x. So I'd have to put a negative 4 here, a negative 1/4 out front. Again, it gets you back a different answer, but technically they're both correct. I think you may run into something like that in your homework, and I'm not sure if it's one that you can check in the back or not, but there is possibilities that you could have 2 correct answers. Okie doke. Now, I think I've got 2 more here, yes. So hang with me. This is number 5. I'm integrating the entire cosine of 2x squared. The entire cosine of 2x squared times sine of 2x. All right. Now here again, it's not really set up like the first couple problems or the first 3 problems. I know I'm going to need some u substitution because I see trig functions of something other than x, but now I have to decide what I should let u equal. On the last problem, it could have been either one, because neither one of these was in parentheses or under a radical. They were both kind of the same. On this problem though, I see this trig function inside parentheses. And so that kind of tells me that I should probably let that equal u. And now I have to figure out du. Derivative of cosine is negative sine. So then I have to take the derivative of the 2x, which is 2, and putting that all back together, it would look like this. Negative 2 sine of 2x dx. That's what I need for du. So let's see what is going on. That is u. So in our next step, it should become u squared. And then I need all of that for du. So I'll have to put a negative 2 over there and a negative 1/2 out front. And then this should work out okay. Go ahead.
Why is it a negative?
Right here.
Yeah.
We're doing the derivative right here, kind of backwards from integrals. If I was integrating cosine of x, it would be just sine of x. But when you're doing the u and the du part, we're going back to derivatives. So that is kind of hard to remember which one's which. All right, now I'll keep the negative 1/2 out front. And let me start by just rewriting this part as u squared du. Now it just becomes a matter of adding 1 to my power and putting my new power on bottom. So right now it's u cubed over 3, but let's make that look a little bit better. I can keep the negative on top or out front. It doesn't really matter. And if you want to put parentheses around the u part, u was cosine of 2x, you can leave it like that with the cube on the outside. Or I guess you could kind of put the 3 right here in the middle like we did on the last one, and you won't need parentheses. But I kind of like to turn that into just a single fraction, or it would be the same as negative 1/6 times the cosine of 2x cubed plus c. That would also be fine if you want to pull the fraction out front. All right. U is usually what's in parentheses or under a radical. So I kind of went back to that technique for number 5. Now, the very last problem here, and I like this one. I like to put some like these on tests and quizzes because it's a good one. Number 6, we are integrating secant squared of x divided by tangent to the 5th of x dx. Now, there are 2 trig functions here. We've got secant squared, we've got tangent to the 5th. Remember, if you're having trouble deciding which part to let u equal, I'm not really seeing parentheses here or radicals or anything like that. Always go with the part that is a little bit more complicated. We could actually turn that into tangent of x to the 5th power. You could rewrite tangent to the 5th of x as tangent of x to the 5th. That, in my opinion, is more complicated because it's to the 5th power and that is only to the 2nd power. And so that's kind of what's drawing me to this part. Now, once I have it written like this, the part that's in parentheses is tangent of x. And we're talking derivatives here. Anybody remember the derivative of tangent? You can actually take the integral and just switch it around. Secant squared, and looky there, secant squared, it's matching up to what I have. Now I will say that the u is still on bottom, so you might want to rewrite this a little bit so you can see it better. I'm leaving secant squared of x alone, but if I pull that to the top, it can be tangent of x to the negative 5th power dx. That might help us a little bit when I go to rewrite this. So that part is u, and I have everything that I need for du. So we could actually rewrite this as u to the negative 5th du. I'm going to integrate u to the negative 5th with respect to u. All right, so add 1 to my power, put my new power on bottom. We need to talk for just a minute about how to simplify this. This part needs to move, so it has a positive exponent. You can move the negative sign, but you can't move the 4. The 4 has to stay on bottom because it doesn't have a negative exponent. It's fine. So really on top, I can just put negative 1, and on bottom, this is now 4 u to the 4th power plus c. But I'm going to go back and put in what u equaled. So this is actually 4 times tangent of x to the 4th power, or you can write that a little bit better if you just put the exponent in the middle. So -1 over 4 tangent to the 4th of x plus c. Okie doke. I'm going to go ahead and put the assignment up here. There's not too many of them. Got about 12-ish minutes left. So this is C85 from page 341. We're doing 31 to 39 all.